My name's Colin Goodwin, and I'm here wearing my CIBSE hat. So if I just tell you a little bit about myself and why I'm presenting for CIBSE today, I'm an independent consultant for the last 4 or 5 years. You might know me from previous roles of a technical engineering director at Mighty, Dalkier before that, and 3 years as technical director of Bisria. And I went independent about 5 years ago and was approached by CIBSE to assist notionally 1 day a week with their technical program, and specifically one of the areas they wanted someone to help them with was the heat pump guidance and review, and they were asking someone who had some experience of heat pumps. I had very limited, but probably more than most. I'd installed 3 or 4 and had gained some experience in doing that, and that normally means it didn't quite go to plan. I've spent now 5 years with CIBSE and some of the experts. I still consider myself a novice because now I've been exposed to the experts in this field, recognise there's a lot more to be learned and experience to be gained. So that's a little profile about me. I do also do some work with the CEF as a technical advisor on specific projects. So delighted that they invited me here to masquerade in my other role with CIBSE and provide you with a bit of an update of where we are with heat pumps and a broad agenda. So what I'm going to talk through is heat pumps, the drivers, the challenges, the what, the why, the where, what are key things to think about, and a little bit of project pitfalls and feedback, what we know so far. A little bit about how CIBSE engages and brings together knowledge and expertise from various places to give that insight and credibility and how they go through that. I've put something about policy insights. I had the good fortune of only 10 days ago going to Heat Pump Association Policy Insight Workshop, which had representatives from government. And rather than having to do a whole load of reading, I took some notes and just put together the bullets that I took away from what was said by those representatives. So what they know and what they're thinking about, the challenges they want to address, and a little bit of insight what might be coming in the autumn statement. So there's a little bit of policy insight. Then I'm going to run through a little bit of CIBSE guidance, what we've currently produced, what we're in the programme of producing, and who we've collaborated to do that. And the last one with a bit of a throw it out there is innovations, things we know are coming, and if you read the journals and you see something new or relatively new every other week that is an innovation, is it good, is it bad, is it snake oil, they might say, that actually that's clever marketing on an old product or clever marketing on something that isn't really a viable product. So that's kind of the agenda. So why heat pumps? Well, the statements are there really. 85% of homes are natural gas, 25% emissions come from heating. Decarbonisation of heat is essential, and policy and practice has really noted that for the vast majority of premises, electrification of heat is likely to be, for the next 20 years or so, the only really viable alternative. There are other alternatives being worked on, and you'll see them around here. And on larger schemes, some of those alternatives are viable. But at the moment, if we're going to follow the 2050 UK carbon budget, it's highly predicated on electrification of heating for heating buildings. So a little bit about, they're great because it's clean air, a little bit around the demand management. So where can you install them? Pretty much anywhere. If you can install a chiller or an AC unit, you can install a heat pump. There's also other opportunities in different heat sources. So that's great. New build, awful lot easier than retrofit in design and install. But retrofit has some challenges, but it has some upsides because you can measure your actual heat usage. My advice to anyone thinking about a retrofit project and a heat pump, get hold of 3 years worth of data, profile it as much as you can. At least, even if you haven't got the whole year, know what the profile is on a daily, weekly basis in winter and summer, and total consumptions, even if they're only monthly consumptions. So you'll get an understanding of the cyclic nature of your heat demand when it manifests itself, and that gives you an opportunity to think seriously about how to tackle that. Life cycle replacement in non-domestic is very much in its infancy. There's very few people out there doing a life cycle replacement of a boiler for a heat pump. There are a lot of challenges in making that happen, but we'll come to those, and there's a lot of progress being made as we can get better at it. Huge range, and actually CIBSE's involvement through heat pumps back in the domestic sector has increased massively in the last 5 years. Previously there wasn't much, but now the nature of heat pumps is such that technical information is required at that level. Great opportunities are simultaneous heat and cool. So anyone who's out there thinking about a heat pump, my first challenge you, if you're thinking about changing a chiller, please consider a heating and cooling heat pump. If you don't, I'll probably cry, because it really is an opportunity that you're already making the capital investment, you're already putting the network, and you've got free heat, and it could be the infancy of that funding the first steps to decarbonise. So third, fourth and fifth generation networks I've mentioned. I won't talk any further about networks or I'll lose what time we've got, but it's a big opportunity in the larger commercial world. So there are a few naysayers, as you probably know, about heat pumps, and if I ever go to a dinner party, my wife bans me of mentioning it, and I try and avoid anything to do with, I'm thinking, Colin knows something about that. No, Colin doesn't know anything about that, because what most people know is what they've read in the tabloids, and my view is we need to improve the confidence of our installations, and you gain confidence. You don't just expect it. So once we have got a mature market, we are delivering these well, we install them well, we operate them properly. Heat pumps are great. They deliver everything, the promises, everything it says on the tin, it delivers. Any of those things not done, it doesn't. And there are plenty of reasons why that may not work. So some key things, I mentioned new builds are easier, but think about lower flow temperatures and hydraulics. Think about retrofit. Think about the flow temperature, higher COPs. There's something called the Carnot efficiency, and the engineers in the room, especially the clever ones, unlike me, will know a lot about Carnot efficiency, and you can't beat physics. So if you want, the higher the profile that you want to achieve between the low side of 4 degree outside and 85 degree flow, your efficiency has to go down. Unless there's a revolutionary breakthrough in physics, that isn't going to change. So in electrification of heat and using a heat pump, if you can lower your flow temperatures, larger emitters, or find that your emitters are big enough, that's great, and you can make great progress. What I'd probably introduce to that, also think about return temperature. So in my career, I started off taking oil boilers out, putting gas boilers in, found out that you didn't want a low return temperature because you corroded out the back of the boiler. So we put in things like back end protection and deliberately raised the flow temperature. A lot of heating engineers forgot about that and carried on doing it. We then put in condensing boilers, get the flow temperature down, you get greater efficiency. Weren't very good at it, still aren't very good at it. We then brought CHPs along. Even more important, control your flow temperature, or your return flow temperature. Getting the return temperatures down, no, we still threw in 3-port valves and 4-port valves and made sure we got as much as heat that the boiler emitted back to the boiler as quickly as possible, and really did not have the opportunity. We've now got heat pumps. If you don't control the return temperature actually onto a heat pump, don't buy a heat pump. It's as simple as that. They are brilliant things, but you use them in the wrong way, and that is one of the key considerations, to think about the hydraulics and think about that control of return temperature. So lots of opportunities and resources where you get the heat from. So especially in hospitals, you've got the opportunity of a whole host of waste heat avenues to think about, either on a micro small heat pump in a hydrotherapy pool through to much larger opportunities and being the base load of a bigger heating scheme. And there aren't many people who are thinking about a heat network wouldn't like to talk to a hospital as an anchor load, because you are there with some certainty. You'll talk about a 15-year likelihood of operation. You'll have some certainty your loads won't change significantly. The purpose of you being there is unlikely to change. You know, we'll all continue to have the need for that service in that location for quite a period of time. So they are fantastic in terms of the technical load opportunity with the financial investment case. So I would impress on any director of estates or any engineers out there thinking about putting the business case, think a little bit wider than just your hospital. Think about hybrid and transition. This is a transition to low carbon. It's not heat pump or nothing. Boilers are still good, they're still efficient. In fact, there's a few people in the audience probably put them in with me, and they were the saviour of that day 20 years ago. Condensing boilers, probably CHPs 10 years ago. They fixed carbon, they fixed cost. Now the decarbonisation of the grid has changed that dynamic, and we now see them as the pariahs. It may well be that someone stood on this stage in 10 years' time telling you what a brilliant idea the next set of technology is, and it's no longer heat pumps. So that's just an insight of where we are. So pitfalls, electricity capacity. If you're thinking about a large-scale heat pump, you need a large wire. The DNO are very helpful, although they don't provide any service level agreement to your response for requesting for it, and they've never made any investment, as far as I'm aware, ahead of service need. So they might know you're building a new hospital, but they won't be joined up in building a bigger infrastructure to serve it, and this can make massive challenges to your design program. Because if you're designing heat pumps and you don't know you're going to get the power, it will cause you a whole host of problems and challenges. Respecting the operating sensitivity of spark gap. But that's broadly the difference in price between the gas price and the electricity price. I'll come on to the next slide to explain that a little bit further, but that really drives your revenue business case. Water treatment, well, we've always had challenges in our industry in water treatment. What I would say, if you're retrofitting or thinking about heat pump installation, think about your water treatment, get some early analysis done, get people who understand the background in BG50, BG29, which are the two BSRIA guides, one about operating closed water systems and one about the cleaning and commissioning, the cleaning and flushing phase, so how to do that well. And of course there's another standard, which is a European standard, I think German standard, actually, a VDI 2035, often referred to as just VDI, and that's broadly demineralisation. So if you've got demin water, that will be, and often heat pumps bought from within European supply chain state that somewhere in the small print, that if your water treatment is to VDI, they warranted, and if they don't, they might not. So look out for that pitfall. Noise. They're no more noisy than a chiller. So if you can put a chiller or an AC split unit, you can have a heat pump. Two things to be wary of. The time of day you're going to be running them will be different to your chiller and heat loads. Typically, you'll want to run heat pumps through the night, often at a sound profile and level where the rest of the ambient noise is low. So you have to think a little bit more carefully, otherwise you will fall into problems. A German manufacturer again spoke to me about, what is it with you British guys? You want a special. You don't want the 4 metre by 2.5 metre unit that I can put on the pallet. You want it 4 metres square or 3 minutes square. And can the pipes come out vertically or sideways? They say to us, well, they can, but then all of the testing, the noise criteria, how that system reacts is almost untested. So I would promote where possible to use standard builds and arrange your HVAC network around that. As a refrigerant choice is important. There's a lot going on with refrigeration at the moment. I'll just to run through some of the highlights, the UK F-gas regulations are still set at what they were 2016, I think, maybe 18. The EU have moved on, and 3 years ago we were expecting to have the UK response. So post-Brexit we didn't follow EU, but we are following the EU one before. We're expecting from DEFRA, and it was promised 3 Christmases ago that we would have a consultation document out about what refrigerants are going through and what's their life cycle. My advice probably would be to think along the European standard for 2 reasons. One, there may be some legal challenge around whether we can go completely against that standard, but equally a lot of the manufacturers, a lot of the availability of equipment will be coming out of European design, European markets. So that's quite interesting. Pressure systems with new refrigerants. I've encountered at least one CO2 installation that ran CO2 all around the network, and it wasn't until the pressure systems AE got to look at it, discovered that the rating on all the copper pipework throughout that install wasn't to a PSSR rating. So think about, if you are on relatively novel ground, an application on changing this, think about what you need to do. A2, refrigeration. I've got a little circle there around A2L. R290, very popular refrigerant in heat pumps and air conditioning units at domestic scale. R290 is propane, which in a small machine is only a couple of kilos. Propane as a refrigerant is invisible, doesn't smell, but is very flammable. You start scaling up, you start putting heat pumps into installations with an R290 component. They become, what you've got to remember is, it's not a sealed system. It's a sealed system all the time. It's sealed. Malfunction or leakage of that system is likely for that refrigerant to leak. So you have to think about the explosive atmosphere and possibly ATEX, whether you can retrofit R22, and there's a big worry that these walls of R32 units could be changed to R290. Yes, they could, but you've now got to move them all about 4 meters apart, because if one goes bang, you've got a Catherine reel around the side of your building of a daisy chain of possible explosions. So it's really important. Blends is only something that's really come into refrigeration technology in the last, or in the building services refrigeration technology in about last 4 or 5 years. So those refrigerants with R's, and there's lots of figures, typically are a blend of more than one refrigerant to get a wider envelope, better performance. In operation, you find when those blends split, a small leak leaks one part of the blend and not the other part. And that completely changes and baffles the hell out of your service engineers to understand, well, it's gassed up and they've regassed it, but the blend has changed over time, because it doesn't always leak out of the system in the same in the same proportions that you put it in. So that's an important aspect. Spark gap. I'm not going to go on too much about the spark gap, other than this is I think 2022 data. Broadly hasn't changed very much. And guess what? There's 35 times more heat pumps are sold in Sweden than UK. Well, I could put a heat pump in Sweden and make it an engineering success without doing anything other than installing it. COP of 1. It's really difficult, although I'm sure there's talent out there to install a heat pump at a COP less than 1. But generally, it will work financially. The challenge we have, if our COPs on standard tariff ratings aren't 3 to 3.5, we don't break even on our revenue costs. So I take that as a technical challenge rather than a fiscal one. So our COPs of our SCOPs have to be best in class, and we have to be better than Sweden, Norway, and all those Scandinavians, because their systems are good and they've got lots of knowledge on how to do it, but they don't hit 3.5 every time. So the next was really a little bit of an insight into what CIBSE are doing and who they're engaging with to produce guidance. So in gaining experience and knowledge and publications, it's really important to get as much feedback from as many parties and practitioners as you can. So the heat pump liaison groups have been going about 5, 6, maybe 6 years. I'm involved with it, providing a CIBSE secretariat. So please do reach out to me if it's something you'd like to be involved with or engaged in. They talk about the current aspects, what guidance is coming out, and we'll mobilise around legislation consultation. The next one CIBSE are involved with is ACRIB, and that's where refrigerations largely are discussed, and that's in a wider context than building services, but is a useful umbrella organisation. They're getting very closely involved at looking at competencies. The REFCON certificate for refrigerant handling was fine, but guess what? R290 doesn't come under REFCON, so what do you need to be competent to handle REFCON, given the risks that it might go bang and all sorts of other things. So there's a host of new thinking and legislation. The next one is Domestic Building Services Panel. I mentioned that. It's CIBSE's best-selling document. I've been a member of CIBSE nearly 35 years. Until 3 years ago, I'd never heard of it. It's a amalgamation that CIBSE lead and provides guidance at technician level to install largely at local residential domestic level. So up to perhaps a 45 kilowatt machine at the top end, but it's probably going to be more domestic level. But it does apply that if you're thinking about healthcare estates with lots of medical centres, practices in that are peripheral. So that can be a good approach for design advice. So I said about the policy insights from the workshop. What was I hearing in the policy insights workshop we had over in Westminster 10 days ago? And I'm just playing that what I heard. And we had presentations from policy leads at DESNES, the Carbon Change Committee, who are the group who are not a government department, they're a government advisor, and also from IHEEM Treasury. So what I heard from them, they recognised the problem of the spark gap, it being a fiscal element. They recognised how do they incentivise low carbon tariff rates and smart and push tariffs, and their experience there was they didn't invent or push the EV charging tariffs. The energy companies took that on themselves to gain market share. So there's an element of them wanting to inspire, encourage the market to move to provide better tariffs if you've got low carbon technologies, and especially if that's controllable as to when you take the demand. They did recognise the D&O challenge and the SLA and the investment. One really interesting thing for me, so the Carbon Change Committee just done their 7th carbon budget. So every year they do a budget of how we're going to get to net zero by 2050. The takeaway from me from previous carbon budgets, they had zero or minimal, less than 1%, they thought was going to be in decarbonisation of heat in buildings, would be from hydrogen. So they've almost precluded that as being something that will be a standard. I think in the context from health estates, don't discount hydrogen because it really depends on where you are to the hydrogen networks that are going in and whether you can be an off-taker to that. But in terms of if you're in the middle of leafy Surrey, it's unlikely you're going to get a hydrogen pipe anywhere nearby in the element before 2050 is what I took from that. So what do they also recognise? Well, delivery and confidence and scale, and they were talking about capacity and capability. So capacity of the market, the supply chain, the expertise, experience, trainees, and all sorts of investment that are going in there. Talking about regulatory incentives and also consumer protection, the latter I suspect more at the domestic level of consumer. And they were talking about challenging the industry and others for more data and evidence that heat pumps are working, and this is the this is the benefit. So I'm sure they'll be reaching out, and they already are looking for good heat pump case studies. So they were talking about what's their program investment. PSDS, they said, was a fantastic success, so they're stopping it. I did say it got my vote, but that in itself wasn't a politically enough incentive, and I suspect you got a lot of votes in this room. But in terms of other things, if you've got £1 billion to spend right now, and you're challenged in the Treasury, and that's roughly what they'd need to reinvigorate the PSDS program. It's numbers of that ilk. Their investment has gone elsewhere. However, they recognise finance is important, and public-private finance, the Treasury were starting to state that heat as a service is likely to be in the autumn statement. If it's got this far down the process, I suspect it's likely to happen, and some other tax incentives. So that was the policy update. I'll try and canter through this because some of this is the guidance that CIBSE have already produced. The most relevant one is probably AM 17, which is non-domestic large heat pumps, which is a solid document written by an expert author and panel. My involvement was project managing that rather than contributory. So I was probably one of the first readers of that rather than a huge contributor. So, and from that, CIBSE do run a training program of mastering the application of heat pumps, largely based around that. So one day, so if you are in a world that you think I'd like to know more and understand a bit more about how to do it, that is a way to accelerate either yourself or any of your team. So they're the ones we've produced. What are we doing next? We're doing one that should be out shortly on TM51, which is an update of a rather old document, 2006, I think it was, on ground source heat pumps. My view is they're great, but you have to really think about all the stuff that's in the new guide about geology and planning and all the constraints of getting the waste heat collector in the ground, permissions up and running. Once in, fantastic, they're quiet, low noise, generally the best way to heat. TM39 is a new one that's just in technical draft now, and that's all about energy metering, which goes back to my earlier point. If you've got great metering, you can do great things in your design. And the other two, I won't go into detail, but because they are domestic market orientated. So I think you'll be glad to hear this is the last of my slides, and if there are any questions, I hope there's some people in the audience for good answers. So innovation, what next? So as I said, I've gone through a few iterations in my career and ended up taking out things that I installed 15 years earlier, and I'm sure a few of the younger faces are probably thinking it's surprising it's only 3 or 4 looking at me, but also recognising in their careers, whatever you're doing now, you will probably come back to the designs and the buildings that you were proud to hand over and commission and have to go back and look at them again. So what's sort of coming through, there's quite a lot of technology innovations and package units coming on across that are hybrid or bivalent and heat pump solutions as a package service unit, which is great. If it's built in the factory, configured in the factory, all the stuff and design challenges we have about heat pump operation probably go away. Because if you can buy a package air handling unit that does all the low carbon stuff, reclaims the heat from the, upgrades the extract air using a heat pump into your heating, fantastic, they're all good stuff. Ambient loop systems and networks are great, where waste heat is now very usable at levels of heat that we didn't consider before. We certainly, 20 degree water, not even have to, putting something in the network, not even have to insulate the pipes, is a revelation of how much water you move without 8 or 10 inches of insulation. So that's all quite interesting. Higher temperature products are coming on the market, which is great for retrofit, but beware on SCOPs if you're putting it into new build. Solid state heat pumps has come to my attention only in the last probably 3 or 4 months, possibly a wild card. But I could have said that if I was still on this stand 20 years ago and we were talking about LED lights. So it might be you're taking out the heat pumps that you're putting in today, in 20 years' time, is that going to be a technology? So that is also mentioned in a couple of government policy statements as it might be a technology breakthrough. But then I've also dealt with a few things like I'm trying to get the technology. It was going to go into cars, but it was going to basically hydrogen take gas. I'm thinking I'll come back to it. Sorry. Integration with HVAC and low carbon products, taking solar heat, upgrading that into a heat pump year round is largely a good solution if you've got an element of sunshine or solar energy you could use. Feeding that into a heat pump is great. Refrigeration's a lot of opportunities that are coming through, and all of those innovations will improve. And then heat pumps, what next? I'm looking forward to seeing the journey. I'm hoping to be able to contribute it in some small part. So that, I think, brings me to the end of my update. Sorry, it was quite high level. Didn't really go into a lot of detail, but happy to take any questions on what I presented or on things wider around what CIBSE are doing and any aspects. So were there any questions?
Colin, with all that you've done with CIBSE and with CIBSE, how could we create an accreditation scheme for people designing heat pumps? An awful lot of systems are built in, you're retrofitting a retrofit because the previous ones didn't take account of things like waste and flammability. Is there any movement towards an accreditation scheme?
Well, there is some noise, a lot of noise about competency in construction generally, and heat pumps are included in that. One of the guides we're working on right now is AM 17.1, which has just started as a project, so it'll be 2026, maybe early 27. It's published specifically looking at how to retrofit a heat pump. It does look a little bit at competency and guidance, but largely that will come later. But it is really looking about some of those things that retrofit's more difficult. Done well, it's brilliant. Done badly, it's rapidly not. So there is a piece of work going around retrofit specifically in non-domestic. Competency is really interesting, but I think is probably a further discussion, because I think we can talk about almost every aspect. So